am Mayra Ventilio from BSE 3B. In this video, we are going to study state analysis of the control system. So we are going to discuss steady state error. So without further ado, let's get started. So here, we can see that steady state error is the value of error when t goes to infinity. It justifies or measures the accuracy of the system. Generally, this error arises due to nature of inputs, due to types of system, or due to nonlinearity of system component. Generally, what is meant by this error? So, if your actual output is not matching with your input, then the difference between those two are called error signal. So here, we can say we have a negative feedback on the or we have a negative feedback system where this is the input, which is the R of S, and we have feedback, and we can say that this is a negative feedback. Then the system are having a transfer function of G of S, and of course we have output, which is the C of S. Then from feedback, we have feedback gate, which is the H of S. So you can see this is our system. So input and feedback, that would be an error. So we can say that it is E of S. Now, this output C of S and the input system for the feedback system. So, what will be the output of this feedback? So, the output of this feedback is that will be the input of transfer function of H of S. So, input is C of S into H of S. That would be output over here. So, C of S to H of S will be signal. So, error signal is the difference of input, which is R of S, and feedback signal, which is C of S into H of S. So, we can say that error signal is E of S is equal to R of S minus C of S into H of S. So now, what is my output signal? So for the output signal is C of S is equal to E of S into G of S. Now, to have error signal, C of S will be pleasing. So we have E of S with respect to H of S and G of S. So all we want is to eliminate the C of S, and we want to know how E of S solve R of S, G of S, and H of S. So now, we'll be placing C of S to the equation of error signal. So this will be the equation 1, and this will be the equation 2. So by placing equation 2 to equation 1, so that is E of S is equal to R of S minus E of S, G of S into H of S. E of S is equal to R of S divided by 1 plus G of S into H of S. So that is the error signal. And let's have error signal in terms of time domain. So now, all we need to have is inverse Laplace of our error signal. So that will be E of t is equal to inverse Laplace of E of S. So, if we're going to distribute the given answer or the answer of E of S that we've solved earlier, it will be E of t is equal to inverse Laplace of R of S divided by 1 plus G of S into H of S. So if we are doing the inverse Laplace, we are solving the error in time domain. Always remember that if you are doing the inverse Laplace, then we are currently finding the error in time domain. Now, if we want to calculate steady state error, that is E of S equal to limit t turns to infinity E of t. And if we want to calculate steady state error based on Laplace domain of error function, that would be limit S turns to 0, then S E of S. And if we're going to distribute the answer for the E of S, then it will be limit S turns to 0, then S R of S over 1 or divided by 1 plus G of S into H of S. So that would be all about the steady state error. Thank you for listening, and I hope you enjoyed this video, and I hope you learned something. Again, thank you. Bye. Stay safe.